Hello, cat aspirants. Welcome to another episode of Bell the Cat series. Today, we will be looking at the police station problem from DILR section of CAT 2023. This is one of the most trickiest problem, but it takes less time to solve. So, if you are able to solve this problem in under 10 or 12 minutes, then be assured that you will be able to score at least 95 percentile in DILR section of CAT exams. So let's look at the problem first. So we have 6 stations marked at letters 1 to A to F and 4 teams 1 to 4, which we will be patrolling in these streets connecting these stations between 9 and 12 every day. Also, we know that to cross each street, it takes a team 30 minutes of time, and all the teams they must start from station A and reach station A towards the end of the time, that is at 12. Also, we have certain information with us. So none of the streets have more than one team traveling along in any direction at any point in time. This is a universal statement which we need to remember throughout solving the problem. Then statement 2, 3, 4 state different teams at different stations at different times. So they give some values like which team will be at which station at what time. So we have this information regarding pretty much all of the teams. Then statement 5 and 6 are again universal statements. That means we need to be cautious that these statements are followed whenever we are trying to assign any value to any of the teams. So team 1 and team 4, they can only patrol the street connecting stations A and E. The other two teams, 2 and 3, they will not come in this particular street. Also, team 4, it will never pass through stations B, D and F. That is almost half of the stations it will never cross. So first step, we would tabularize the information that we have and identify what we need to find. So we have 4 teams in 4 rows in column 1. Then between 9 to 12, we have 6 slots of 30 minutes each. Hence, we are dividing the time in 6 slots. And what we need to do is, we need to now fill out this information where each team is in which particular station at what particular time. So now let's look at each team. We will be starting with team 4 because we know that it can only travel between stations A, C and E. It cannot travel beyond these 3 stations. So we'll start with team 4. Team 4 is at E at 11:30. If it is at E at 11:30, that means it needs to travel from E to A between 11:30 to 12 because it needs to end up at A. Hence, it will be traveling from E to A between 11:30 to 12. Again, if it is at E at 11:30, that means it has to travel from A to E from 11 to 11:30 because it cannot travel from station F or D. It can only travel between these 3 stations. Hence, from 11 to 11:30, team 4 will be traveling from A to E. We cannot extrapolate the values beyond this because if it is at A at 11, then it can come either from C also or E also. So we yet don't know what value that would be. Hence, this is all we can put for now for team 4. Next, we have team 1, which is at B at 11:30 and at E at 10:30. If it is at E at 10:30 and 11:30 it is at B, that means it will have to travel from E to A and then A to B because it takes 1 hour for a team to cross 2 streets and it has to reach B by 11:30. That means it will be traveling from B to A. First, it will be traveling from B to A because it needs to reach A towards at 12 o'clock. So first let's mark B to A first, and then we know that to travel and to reach B at 11:30, it needs to travel from E to A, then A to B. So these two values can also be freezed. Next, we have team 3. So team 3 is at D at 10 and E at 10:30. That means it will be traveling from D to E between 10 and 10:30. So let's put that value here. Next, we have team 2. So team 2 is at E at 10. Now, it can travel to A, D, or F. Since it cannot travel to A because it won't pass through AE, therefore, it has to travel to F or D. But the street between E and D is already occupied by team 3. That means it will have to travel from E to F during 10 and 10:30. So this is all the information that we can get from the points that we have already been given. Now, let's freeze this particular information first. And now we will be trying to use our reasoning skills to put the other slot informations that's possible. So let's look at the 10 to 10:30 slot first. Why I am considering this particular slot first is because I already know two of these teams where are they during this particular slot, and I also know where team 1 will be reaching at 10:30. Therefore, I am starting off with this particular slot. So now see this. Team 1, it needs to reach at station E by 10:30. So from where it can come? It can come from F, it can come from A, or it can come from D. But since E to F and E to D, these two paths are already occupied by other teams, that means team 1 will be traveling from A to E only in this particular scenario. So let's put A to E here. Now, let's consider team 4. So team 4, it needs to reach A by 11. A by 11. So from how it can reach A by 11? Remember, it can only traverse in A to C and A to E paths, streets. So to reach A at 11, it needs to go from A to C and back from C to A. That's one possibility. Or it can go from A to E and back from E to A. So it has to start from A and reach C or E and then come back from C or E back to A. That's the only possibility it can travel. But between 10 and 10:30, A to E path is already occupied by other team. Hence, team 4 will have to travel from A to C in 10 to 10:30 slot and then back from C to A in 10:30 to 11 slot so as to reach A at 11. So let's put that information as well. Now I have already filled the 10 to 10:30 slot. Now I will be considering the 11:30 to 12 slot. Why I am considering this slot now? Because I know that all the teams are reaching point A, station A at 12. So, and we have four possible options through which team can reach A. It's B, F, E, and C, out of which B and E are already occupied. So the only options are F and C. So either team 2 will be coming from F or C, and same with team 3. So let's consider team 2 now. So team 2, it's at F at 10:30, and let us assume team 2 is coming from F at 11. So it will be going from F to A at 11:30. So it has to reach F by 11:30, and it is already at F at 10:30. So if it is at F at 10:30, it has to go from F to A and come back at F, or if it has to go to F to E and then come back at F. In both the cases, it will be there at 11:30 at F. Then it can happily go to A from 11:30 to 12. So team 2 can come from F. Now it can also come from C because this is at F right now. It can go to A and then reach C, and then from C can come back to A. So it will go from F to A, then A to C, and then C back to A. So team 2 can actually reach point A from both F and from both C. Now let's consider point team 3. Team 3, let us consider it is reaching A via F. So it has to reach F by 11:30. It is at E right now. And remember, it cannot go to E to A because it doesn't travel between A and E. Hence, it will be traveling from E to F only, or D. But if it goes to D, it cannot reach F in time. Hence, it will have to go to E to F. But if it goes to E to F, then it has to go somewhere from F, either to A or E. Hence, it's not possible for team 3 to reach F at 11:30. That means team 3 will be coming from C only. Let's check, can it come to C at 11:30? It's currently at E. So it can travel from E to D and D to C. That is a possible path. Hence we know that team 3 will be coming from point C to A, from station C to A, from 11:30 to 12. Now the only option left for team 2 is to come from F. So it will reach it from F to A in 11:30 to 12. So this is the information that I have. Again, I am not filling these two slots for team 2 because it can go F to E and then come back to F, or it can go from F to A and come back to F. So these two possible options are still there. Maybe after some time, I'll be able to narrow down on those two options. Now I'm considering the 9 to 9:30 slot. So in 9 to 9:30 slot, we know that every team is starting from A, and every team is starting from A, and there are only 4 possible options we can go from A to C, D, F, and E. So let's consider first team 3. Let's consider 3 for a minute. So it needs to reach D by 10. If it needs to reach D by 10, it cannot go through A to E. Hence, it will have to go from A to C and C to D. So let's put that information. Now let's consider team 2. Team 2 has to reach E at 10. And it cannot travel from A to E again. Hence, to reach E, it will have to go via F. Then only it can reach E in time. So it will go from A to F and F to E again. Now let's consider team 1 or team 4. We should have considered team 4 because team 4 is very simple. Team 4 can only travel between A to E, right? So it will have to travel from A to E and then back from E to A. Team 4 is the simplest of all. And the only option remaining for team 1 is now to reach A is it has to go from A to B and from back B to A. So I have filled all the information that I have. And for team 2, I can now actually put 2 paths. As you remember, team 2 has to go from F to A or F to E and then come back from A to F or E to F to reach F by 11:30. So this is the final solution that I can arrive at. Now let's go through the questions. So which one among the following stations is visited the largest number of times? Let's consider station C. So we know that station C, if you see, team 1 is not going to station C at all. Team 2 is also not going to station C at all. Team 3 is going to station C once and twice. And team 4 is going to station 3 once. So station C is being visited 3 times. Station E, team 1 is going just once. Team 2 is going once or twice. Team 3 is going once and team 4 is going twice. So station E is being visited at least 4 times. It can go up to 5, at max 5 and at least 4. Station D is only being visited by team 3 and it's twice. So station D is also twice. Station F is being visited by team 2 thrice That's it. At max 3 times. At least 2 times and at max 3 times. Hence, we can easily see that station E is being visited the largest number of times, which is 4. At least 4. So option B is the correct answer. Then, how many times do the teams pass through station B in a day? Station B, team 1 passes through once and twice, and no other team is passing through station B. Hence, the answer is 2. And only team 1 is passing through station B twice in a day. Which team patrols the street connecting D and E at 10:15? So at 10:15, from D to E, team 3 is patrolling that particular street, which is option D. How many times team 4 pass through station E in a day? Team 4 passes through E once at 9:30 and once at 11:30. So 2 times. Hence the answer is 2. Then lastly, how many teams pass through station C in a day? So we just saw this. Team 3 and team 4, they are passing through station C. Team 1 and team 2, they are not passing through station C. Hence the answer is 2. Option D. So this was all about this particular problem. Hope you have learned something today. Tell us in the comments what DILR question you want us to solve next, and we will try to include it in our next episodes. Till then, stay motivated, stay focused, and we will see you in the next upcoming sessions.